Hi everyone. In today's class, we are going to discuss about the function of complex variable, and we'll see that how we can define a function of complex variable and what is the need of it. Moreover, we will talk about its limit, continuity, and differentiability in today's class. So now let us start the discussion by just introducing that what is the need of complex number or imaginary numbers. So now there's a term which is known as a mathematical modeling, which is used to model many real-time problem in terms of mathematics. So over there, many times we face the equation, if I am talking in terms of a differential equation, so many times we got an equation like d2y over dx square plus let it be y is equals to 0. Obviously, you know this is a second order differential equation, and the nature of the variable y is defined on the basis of the solution of this equation, and the solution is decided on the basis of the roots of this equation. So if I convert this equation in the general form, it will look like x square plus 1 equals to 0. Leave it how it comes. Now just focus. Since suppose that if I am having an equation of the form x square plus 1 equals to 0, and I need to know what are its solution, why the solution is needed, so that we can decide the nature of variable, and on that basis the relevant information can be find out from the system. When I'm talking about relevant information, means what? It may be related to the performance of the system, related to the nature of the system, and many more things. So this is the equation that we are having. Now, if I need to solve it, what I will get? I will get it as x square is equal to minus 1. If I take a square root on both sides, so x equals to plus minus root of minus 1. So now, in real number system, we didn't know what it is. Under root of a negative number is not defined in the set of real numbers. So basically, now we stopped over here, since if we restrict ourselves up to only real number, we didn't have the solution of this quadratic equation, and on the same time, we don't have the solution of this differential equation, which is a very big problem because this differential equation is generated from the some real life situation, some real life phenomena. So now this is the need that we need to extend our number system. So in past, the mathematician realized this also, and they introduced a new number system, which is known as the complex number system, which is known as a complex or imaginary number system. Now, this is the need of this number system, and this is the extension of the real number system. We know that there are many number systems like real number, whole number, integers, rational, irrational, real. So out of these, we have in the past, mathematician introduced a new number system, which is known as the complex number system or imaginary number system. And how they define this? Now here, the problem is only due to this under root of minus 1. This under root of minus 1, this is the problem that we are having over here. So they just decide wherever we are having a negative number in the root, it will be denoted by iota or simply a number I. A notation I is there. So I can say wherever we find I squared, it will be replaced by minus of 1. Wherever we find I squared, it will be replaced by minus of 1. So on the same time, if I put it over there in this equation, so what I will get it as x is equals to plus minus I. It means what? The quadratic equation or the differential equation that we are talking about now is having a solution in the form x is equals to plus minus I. X equals to plus minus I. The equation, the model that do not have the solution earlier, once the complex number is introduced, it is having the solution now. So this is what we are having. This is the need that we are having. for complex number system. I hope it's clear to you. Generally, a complex number is denoted by Z, and it is having two components. One is known as the real part, another is known as the imaginary part. So a standard form of a complex number is what x plus minus iy, or sometime also written as xa plus minus plus ib or plus minus ib. This is the standard form for a complex number. What is x here? X is called as real part of the complex number z, and y is called as the imaginary part for the complex number z. Understood? So this is how a complex number is started and what it exactly. Now let us move on and see what is a function of complex number, because the topic for the today's class that we are having is function of complex number. So function of complex number. Let us talk about, when I am writing the term function, I hope it's give you clear indication that what is exactly. A function is what? A function means what? If I want to relate it with the general example, general life, realistic example, a function is a machine. A function is a machine where we will give some input and will get some output. There are some input and there are some outputs. So if I am calling this as a function, so this is what we are having a function. If I am talking a simple function like f of x is equals to x square plus 1. There is a machine, when x is the input given to it, it gives the output as x square plus 1. Now suppose that I need to know if input 1 is given, what will be the output. So simply if I put x equal to 1 in this machine or in system, what I will get? It will be 2. So this is what a function, or how a function is defined in the real life system. Now here, if you see, we are talking about function of a complex number, a function of complex number. Here, if x is a real variable, we will call it as a function of real number. But on the same time, if in place of fx, I am taking the variable z, then this is known as function of complex variable, and it is denoted by w, a new variable. So w equals to fz is a function of complex variable, where z is the complex number, where z is a complex number. So this is what we are having, a function of complex number. I hope you got the clarity that what is the need of complex number and how exactly we defined it and what we mean by function of a complex number. Moving ahead, so the standard notation till we get is what w equals to fz. Now w is a function of complex variable, so it will also of the form u plus iv, as x plus iv, x plus iy is the standard form, and fz means f of function of x plus iy. So if I compare on both the side, what u gives me? U gives you the real part of the complex number fz, and what v gives you? V gives you imaginary part of the complex number fz. Real part and imaginary part. On the same time, there's a one thing which is known as the, or before that, like now I'm going to talk about the more applications, some more application where the complex number can be used. One of the application, one of the used, I already discussed from starting, like when I modeled a physical phenomena in terms of a mathematical equation. So many times we face challenges when the roots of the equation or the solution is not in terms of real number. So that's why we need the complex number. It is used in many ways like science, engineering, many times used in the engineering problems, like if I'm talking about the communication systems, electrical and electronic engineering, in robotics, and in many more places it is used. So this is what some of the application. I just suggest you can explore these application, okay, that how exactly they can be used. I will also cover that how exactly a complex number can be used in the engineering problem, but not in today's class, but it in the coming class. Okay, so this is what we are having, function of complex numbers, w equals to f of z. Now, if I'm talking about the representation of a complex number, so we are having three representation of a complex number. Like it can be represented in the terms of Cartesian coordinate, like z is equals to x plus iy. And if I denote it on the Cartesian coordinate system, so real axis, imaginary axis. In place of x and y axis, we will call it as a real axis and imaginary axis. So on x-axis, we are having x, and on y-axis, y is there. So somewhere here, this is the point z that we are having. This is how a complex number is denoted. This is the x distance on x-axis. This is the y distance on y-axis. Okay, so this is what the Cartesian coordinate representation of a complex number. The second thing, if I convert it like if I am making this is an angle theta, and suppose that this is the distance r. This is the distance r. So if you see by Pythagoras, r will be comes out as what, x square plus y square in under root. And what about theta? Theta will be tan inverse y over x. Simply use the tan theta formula. Like tan theta, we are having tan theta is what? It is perpendicular over base. So perpendicular here is y, base is x. So simply here you can see this is what, y upon x. So we can find out theta. Now I am going to convert this representation x plus iy in polar coordinate system. What is a polar coordinate system? A coordinate system which is in terms of r and theta. Like r is the angle from the positive x-axis in anti-clockwise direction, and what is r? This magnitude is r. Now, if I am using the concept like what is cos theta, so if I am using cos theta, so this will comes as what? X over r, like base over hypotenuse. So it tells us about value of x, so x will be r times cos theta. In the same manner, if so this is what, x equals to r cos theta from the given this geometrical representation. On the same time, what will be sine theta? Sine theta, we already know that it is what? Perpendicular over hypotenuse. That is, perpendicular is y and hypotenuse is r. So what I get? Y equals to r sine theta. So x equals to r cos theta and y equals to r sine theta. So this is what, if I put it over here, what I will get? It will comes out as r cos theta plus I into r sine theta. I can take r common. So cos theta plus I sine theta. This is the another representation of a function of complex variable, or simply say a complex number. This is known as the polar coordinate representation of a complex number. Z is equals to r into cos theta plus I sine theta. Moreover, if I use the trigonometrical result, it will comes out as r into e to the power I theta. It is known as the exponential representation of a complex number. If I use the trigonometrical result, like e to the power I theta is what, cos theta plus I sine theta. So if I use that result, it will comes out in terms of a exponential representation. So simply a complex number, we can represent it as a Cartesian coordinate, polar coordinate, and the third one is exponential in terms of exponential number e. What is theta? The angle that this R is made of positive x-axis in anti-clockwise direction. And what is R? R is this radius vector. Now, moving ahead. So this is the introduction of function of a complex variable. Now, moving ahead. So here we are going to discuss about the three concepts, which is what limit, then continuity, and then differentiability. So now we will talk about the three terms, which is limit, continuity, and differentiability for a function of a complex variable. The first thing I am going to discuss about the limit. I hope most of you know about the limit for function of a real variable. Like if I am having y is equals to fx, function of a real variable, then what we mean by the limit? So let me just explain it with the help of a diagram. Now suppose that I need to find the limit of a function fx at some point, let it be x equals to a. X equals to a some point, and I need to find the limit of the function y equal to fx. Suppose that this is what we are having, y is equals to fx, a function. Okay, and suppose that this is the some point x equal to a. Now, what we mean by limit of this function at the point x equals to a? It means what? When we are approaching to the point a from the left side, that is also known as the left hand limit, and from the right side, also known as the right hand limit. What I'm saying, in case of function of one variable real number system, what we mean by a limit of a function at x equals to a, like if we are approaching to the point x equals to a from the right side and x equals to a from the right side, left side. If in both the way, the limiting value of the function is same, or better to say, the value of the function is same, then we call it as that the limit of the function is exist. The limit of the function is exist. Limit means what? Basically, we are tending to the point A. We are tending to the point A. It's not exactly A. Okay? We are tending to the point A, but not exactly A. So in this case, we will say if left hand limit means what? We are approaching to the point from left side through the curve, and we are approaching to the point from right side to the curve. And if in both the way we are getting the same limiting value, we will say the limit of the function is exist. This is the case of function of one variable, or we can say real functions. Now moving to the function of a complex variable. So what it exactly means? Now function of complex variable means we are talking about w equals to f of z. W equals to f of z, that is f of x plus iy type function, like this. Now it means what? If suppose that this is some point and we need to find the limit of the function at some point, suppose that z is equals to a. Z is equal to a, we need to find the limit. Now here, the same concept I am going to use. If we are approached to the point A from left side, from the right side, if in both the way limit exists, limiting value is same, can we say limit exists? No. Why no? This is the difference. Now we are talking about two-dimensional geometry, two-dimensional function. One is x-axis, another is y-axis. Here it is one-dimensional function, so only one dimension movement is allowed. But in here, we are having two-dimensional function, so we can move in any two-dimensional way. So here, when I'm approaching from left side, right side, from the top, from the bottom, vertically, horizontally, I can say there are infinitely many paths to approach to the point z equals to a. To approach to the point z equals to a, there are infinitely many paths. Now, if I'm using the same concept that we have used in the case of function of one variable, so what should I say? I will say the limit of this function, which is w equals to fz. The limit of the function, which is w equals to fz, will exist if will exist if. So in this case, we will see if when I'm approaching to the point z equal to a, all the paths give the same limiting value. This is what we are having difference for limit in the case of function of one variable, that is real function, and the case of function of two variable, that is the complex function. In function of real variable, only we need to find left hand as well as right hand limit. But in case of complex function, we need to approach to the point from the different possible direction. Now you may ask, sir, why here only two sides and here all the sides are there? The difference is what? Here the variable is x, so we can only move on x axis, but here it is x and y, two-dimensional object, so it can be moved in both the way, like x axis, y axis, and all the things which is passing through that point. So this is what the geometrical meaning of the limit we are having. Geometrical meaning of the limit that we are having. So since we are going to discuss about the limit of a complex function, so it means what, if in a single line I need to tell you what we mean by limit for a function of complex variable. So it means like when we are approaching to the point through all the possible paths, and if the limiting value of the function comes out same, we will say the limit of the function is exist. Now many of you are thinking, like in case of one variable we need to find left hand as well as right hand limit, there we are having the complication. Now here when we need to find the limit through infinitely many paths, so these are infinitely many paths, so how one can find it? It's too complicated, but it's not like the thing. So this is what we are having limit. I am going to take an example so that you will get a clarity that how these all infinite paths can be covered. Okay. Once again, I am not going to give you mathematical definition of limit right now. I just explained to you that what we mean by the limit geometrically. Now, if I am talking about the calculation procedure, that how one can find the limit of a function. So we will find the all possible limits. If all the possible limit give you the same limiting value, we will say the limit of the function exists. If any of them give the different limiting value, we will say limit does not exist. Simple and clear. Let us take an example. The question is asking find the limit z tends to 0 of a function which is z over z bar. We need to find the limit at the point z equal to 0 for the function z over z bar. Now let us try to understand it. Z equal to 0 means what? The point is z equal to 0, that is origin. So I am approaching to the function to this point to all the possible paths. If it gives the same limiting value, we will say the limit of the function exists, otherwise does not exist. Clear? So now let us convert it in the first in x and y terms. So this will be x and y tending to 0, 0 because z is 0, and z means x plus iy, z bar its conjugate, so x minus I. This is what we are having z. Now I am choosing the point along real axis first. So let z is tending to 0 along real axis. Real axis means what? Where y is 0. Real axis means what? Where y is 0. So this is one of the path to approach z as 0. So when I put z equal to 0, what left? I will get it as limit. We are going to put y 0, so only x left over here. X plus 0 over x minus 0. Now x got cancel out. So what I'm getting? 1. So the limiting value of the function when we are approaching along the real axis, what do we get it as 1? Till now, I just consider only one path. Taking one more path, now let z is approaching to 0 along imaginary axis. Imaginary axis means that is y-axis, and at y-axis what we have? X equal to 0. So put x equal to 0, what I will get? It will comes out only y left over here, x is 0, so 0 plus iy over 0 minus I. So what left? Iy got cancelled out. How much is left? Minus 1. So now here is a take. On real axis, the limiting value is 1. And imaginary axis, the value is what? Minus 1. 1 minus 1. What should I say? Limit exists or not? Recall the definition of limit. What it says that if through all the possible paths approaching to the point, if limiting value is same, then we will say limit exists. But here what I get, I just choose two different paths, and through both the paths, the limiting value is not same. Limiting value means 1 and minus 1. They are not same. What should I say? I should say, or I have to say, since two different paths give the different limiting value, it means limit does not exist. Did you got it? Once again repeating. Now, in place of calculating all the paths for the limit, if I simply find two or more paths which gives you the different limiting value, so in that case we will say limit does not exist. So what should I say? Since through the different path we are getting the different limiting value, since two different paths for approaching z as 0 gives different limiting values. Different limiting values implies limit of fz as z tending to 0 does not exist. Why does not exist? Because it is not unique. Why does not exist? Because it is not unique. It is not unique. This is how we have solved this first example. Now the question comes in your mind, sir, how we can come to know that which path we should take. So the thing is that you can use your common sense, like which two paths gives you the different limiting value, or you can try to cover all the possible paths, and if some of them is giving different limiting value, we will say limit does not exist, and if all of them give the same limiting value, we will say limit exists. Now the major question over here is what? How to cover all those paths. So let me just give you the same example again. So now if you see the path that are passing through the origin, these paths. So if I take a common path, which is what? Y equals to mx power n. This is the line which is covering all the paths passing through z equal to 0, 0. This is the line, standard line, which is covering all the path passing through y equal to m into x power n. Getting it? So now in place of getting all the paths, if we see that through this path, the limiting value is unique, we will say limit exists, otherwise not exist. Here the n is decided according to the given scenario, according to the given problem or situation. So if I am taking the same example, like I need to find limit z tends to 0, z over zy, which comes as limit z tends to 0, which is what? X plus iy over x minus iy. Now suppose let z tending to 0 along the path y is equals to mx. I just take the path y equals to mx by taking n equal to 1. So what it gives, we are putting y as mx, so only x limit is there. So x plus I m x over x minus I m x. I can take x and cancel it out. So x can be taken common. So 1 plus I m and upon 1 minus I m got cancelled out. So what the value I am getting? Put x equal to 0. So 1 plus I times m over 1 minus I times m. This is the limiting value that I have obtained. Now, as the definition says that if through all the possible paths you got the same limiting value, limit will exist, otherwise not. So I am getting this limiting value. Can I say this is unique? It is not unique. Why? Because it is depending on m. Like if I am taking m equal to 0, I will get limiting value as 1. If I am taking m equal to some other value, let it be m equal to 1. In that case, it will be infinity. M equals to 1, not infinity, 1 plus I over 1 minus I. Taking m equal to 2, 1 plus 2i, 1 minus 2i. So the different path is giving you different limiting value. It means what? Limit does not exist. So in short, I should tell you, I have to tell you that when you are taking the journal path, this is what? The journal path. For the origin, it depends only the point also. It also depends on the point, that what is the point. So for 0, this is the journal path. And if this through journal path, we are getting the limiting value, which is depending on m. Depending on m is not unique. I will say which depends on the number m. It means what? It is not unique. And not unique means what? Limit does not exist. Not unique means what? Limit does not exist. Suppose that by solving this, I got it as only 1. Let us assume for some example. So now you can see it is not depending on m and it is always same. In that case, I will say limit exists and it's unique and its value will be 1. Get it? So this is what one another way for finding the limit of a function of a complex variable. One way, actually, journal path is important in the case when limit exists. And when you see the question is there whose limit does not exist, so better you can take two paths which gives you the different limiting value, counter things. Okay, it may, like in general path, you can also use this concept. Like if it is function of m, we will say not unique, so limit does not exist. But if it is free from m, we will say limit exists. Now, sometime what happen in place here, I am taking the path y equal to mx. Sometime we should take y is equal to mx square, y is equals to mx cube, depending on the nature of the problem. Y equal to mx is sufficient in the case of homogeneous function. Homogeneous means what? The degree of numerator and denominator is same. But if it is not the case, then beside y equal to mx, we should choose some more paths. Beside y equals to mx, we should choose some more paths. Understood? I hope you understand that how to find the limit for a complex function. Taking one more example. So suppose that this time we are having a function find limit as z tends to 0. Let us take it as z minus 1 over z plus 1. Z minus 1 over z plus 1. So either you can approach it like firstly along real axis, imaginary axis, y equal to x, y equal to minus x, y equal to 2x, y equal to minus 2x, one by one, and can see it. Another thing, I am going to take a general path. So let us convert it first in terms of x and y. So limit xy tending to 0, 0, and what is z? It is x plus iy minus 1 over x plus conjugate, so x minus iy plus 1. Let z is approaching to the 0 along the path y equals to mx. The general path I am taking y equal to mx. Put it over here. So limit x tends to be 0. What left over here? X plus imx minus 1 over x minus imx plus 1. Can't take x common, so put x equal to 0. So 0 minus 1, 0 plus 1 comes out as minus 1. Now what can I say? Is it unique? Obviously yes. Which is unique. It means through all the possible paths approaching to the point 0, 0, the limiting value of the function is minus 1. Which is unique, it means limit z tend to 0, limit of the function is exist. Better to say implies limit exist at z tends to 0. And how to write it? We can write it as limit z tends to 0 for the function z minus 1 over z plus 1 is how much? Minus 1. This is the solution for this problem. I hope it's clear to you that how one can find the limit of a complex function. So let us take one more example. One more thing, most of the time the problem is occur at the origin. If the point is non-zero, then most of the time limit can be directly obtained by putting the point. I'm saying most of the time, it's not always. Most of the time, I am not saying always. So this is what we are having about the limit. The next thing that we are having is continuity. What we mean by continuity? Continuity of a complex number. It is same as continuity of a real number. A function is said to be continuous. If I want to give you the simplest definition, function is said to be continuous if its graph will never break. The function is continuous, you can see from this point to this point. At the same time, if I am having a function which looks like this, so I will say it is not continuous because it is breaking at many x values. It is like the graphical way. But how to check that a function is continuous or not? Because it's not easy every time to draw the graph. So it is same as function of real variable, like if limit exists and if the limit of a function exists and it is equal to the value of the function at the point, then the function is said to be continuous. That is, we will say a function fz, a function fz is said to be continuous. Why taking fz? Because we are talking about complex functions. A function fz is said to be continuous at a point z equal to 0 if the first thing, limit of the function is exist. Limit at the point z0 of fz exists. When I'm saying exist means it must be a finite value. Second thing, value of the function at z0 must exist. Limit exists and value of the function at z0 exists. And finally, these two exist. And finally, I should say the limiting value of fz must be equals to the functional value of fz at the point z0. If this is the case, we will call the function is continuous or continuous at the point z equals to z0. So it means what? If limit does not exist, the function is not continuous. Getting? So firstly, limit important. Then if limit exists, we need to find the value of the function at the point. Second thing. And the third thing, both of them must be equal to each other. If this is the case, we will say the function is continuous, otherwise not continuous. For example, if I take this example, fz is equals to z over z bar, z tends to 0. Can I say this function fz, which is what z over z bar, is continuous at z equal to 0? Can I say it? To say the function is continuous at z equal to 0, I must find firstly the limit and it must exist. Here, you can see the limit of the function does not exist, as already proved. So since limit does not exist, what should I say? This function fz is not continuous at z equals to 0, or can say discontinuous. Getting? So if limit does not exist, function is not continuous at that point. But if limit exists, then can I say the function is continuous? No. Why? Because beside the limit exists, the value of the function at that point is also exist, and limiting value must equals to the functional value. Means what? If I take this example, this is the same one, this example. So here you can see the limit is exist and limiting value is -1. Limit exists and limiting value is -1. Limiting value is -1. What is fz here? Fz is what? Z minus 1 over z plus 1. And what is the point? The point is z equal to 0. So I can say the limit exists and it is -1. Now I need to find the value of the function at z equal to 0. Put z equal to 0. So 0 minus 1, 0 plus 1, it is also -1. So now I say limiting value exists, or I should say, I have to say limit exists and its value is -1. Limit exists with value -1. Moreover, the value of the function also exists at the point which is -1. The final step. The limiting value, now I can conclude that the limit at z0, that is 0, fz is equals to f of 0. Both the things is exist and they are equal. Limiting value is equal to the functional value. So what I should say? I will say the given function is continuous at the point z is equal to 0. Is continuous at the point z equal to 0. So this is how we can check whether a function is continuous or not. I hope it's clear to you. So simply, for continuity, limiting value should equals to the functional value. It means if limit does not exist, function will never be continuous. I hope you understand the concept. The mathematical definition I will talk about the next class, but this is how we can define a function of complex variable, limit, continuity, and how we work on it. To summarize the class, what we have done, we have talked about that what we mean by a function of complex number, what is the need of it, what are the different representation of it. After that, we talked about limit and do comparison between limit of a real number and limit of a complex number. Understood how to find the limit of a complex number, and then about continuity. I hope you understand and try to practice these things. In the next class, we will talk about the differentiability of a complex number, which is also very important terminology related to the coming things like analytic function, harmonic function, and many more things. So now that's all from my side for the class. Thank you. Thank you very much for joining this class.